Okay, this is for section 3.3 on what they call linear programming. First, I want a definition of linear programming. Linear programming is a method for finding the maximum. It's a method for finding the maximum or minimum values of a function given. Linear programming is a method for finding the maximum or minimum values of a function given a system of inequalities representing what they call constraints. What they call constraints. Okay, so a couple new terms: linear programming, and the inequalities represent what they call constraints. You're going to end up doing basically what we did on this last section. You're going to probably graph 2 or 3 inequalities. Most of the time it's 3. Okay, and then there will be an intersection. They usually call that intersection part what they call the feasible region. In geometry, we call it a convex polygon. Okay, and the max or the minimum, max or min, is found by using the vertices of the feasible region. If there is a max or a minimum, it's going to occur at one of those vertices. Okay? And the author has you do just some basic problems first, and then actually takes it into the application. So we're going to go through a just a regular graph first, and then I'll take you through an example. Okay? So on problem number 1, they ask you to graph the following, and they give you 3 inequalities, and then they want you to find the max or min values of the function. This would be the function down here. They're giving it to you in the form f of xy equals 3x minus 2y. So first we're going to graph the inequality x is less than or equal to 5. If it's x equal 5, it's going to graph a vertical line. So at x equals 5, and these are equal, so they're solid. X is less than that, so it would be everything to the right. To the left, sorry, to the left. I said to the right. Okay, and then y, let's graph y is, graph it as though it's equal to 4, y equals 4. Should be a horizontal line. Okay. And then y is less than that, so less than would be everything down below. Okay, and then graph the x plus y is greater than or equal to 2. So I'm going to subtract the x. Remember, if you have to multiply or divide by a negative, you reverse the arrow, but we're just subtracting. So y is greater than or equal to a negative x plus 2. So it crosses at positive 2, and the slope is negative 1. So go down 1, right 1, down 1, right 1. And so I've got something about like so. And the overlap, can you see where the overlap is? I would end up on that one. Where would I shade? Let's see. You'd have 0 is greater than or equal to 2. No, that's false. So, do you see this would be the overlap right here? Looks like a triangle. Do you agree with that on your graph? Okay. Okay, now, what they're saying, and this actually goes, they don't really tell you in this, but this goes back to what they call the vertex theorem. If there is a maximum or a minimum value to that function, it occurs at one of those vertices. Okay, so you need to go through and figure out what's each vertex of that. So, what's that ordered pair? Oh, this would be, looks like -2 and up 1, 2, 3, 4. You get -2, 4. Check my points. Okay. And then on this, for this one, it would be 1, 2, 3, 4, 5, and up 4, 5, 4. For this one, 5, 4. And then for this one, it'd be 1, 2, 3, 4, 5, and down 3, 5, -3. For this one, 5, -3. Okay, so first you graph them all. You find what they call, that yellow part is what they call the feasible region. That's the overlap. And then if there is a max or a min, it has to occur at one of those vertices. Okay, so I'm going to go back and write this down. Okay, so let's do the -2, 4 first. So that'd be 3 times a -2 minus 2 times 4. So 3 times a -2 would be -6. -6 minus 8. I get a -14. Agree with that? Okay, then try 5, 4. Put 5 in for x. 3 times 5 minus 2 times 4. So 3 times 5, I get 15 minus 8, I get 7. Agree with that? Check my arithmetic. And then the last one is 5, -3. So 3 times 5 minus 2 times a -3. 3 times 5, I'd have 15 plus 6 is 21. Now, they're going to ask, what is the max or min, and where did it occur? So the maximum would be 21, and where did it occur? 5, -3. So you can say, and it occurs at 5, -3, if that helps. -3. 5, -3. Okay, and where's the minimum? -14, right? -14, and it occurred at -2, 4. So, you graph the inequalities, figure out the feasible region where it intersects. You got to find the vertices of the intersection and test them into whatever function they give you. They will give you a different function on each problem. Okay? Okay? Questions on that? Okay, now we're going to go through an example and application problem. Okay? Okay? Okay, look at this example. Okay? And first, I want you to take a couple minutes and read it. Okay, and on this one is actually going to be a lot easier not graphing it on graph paper. Most of these word problems, you're better off not to graph it on graph paper. Okay, so first thing, I set the x to be the number of scientific calculators, y is the number of graphing calculators, and now you have to write the constraints. Okay, so if you go back, okay, there's a demand of at least 100 scientific calculators. So x is greater than or equal to 100 scientific calculators. Okay? And because of the limitations, no more than 200 scientific calculators. So our X is between 100 and 200. So that is one constraint. Okay? The demand is at least 100, but we can't make no more than 200. Can we make 200? Yeah, so that's okay. Okay, now look at the Y values on the graphing calculators. The demand is 80, so we want at least 80. So Y is greater than or equal to 80. But we can't make, because of the limitations on production, okay, we can't make no more than 170. So less than or equal to 170. So that's the constraints on the graphing calculators. Okay, and now to satisfy a shipping contract, a total of at least 200 calculators. Okay, at least 200. So what's a constraint for just that sentence? Yep. To satisfy a shipping contract, a total of at least 200. Greater than or equal to 200. But what's greater than or equal to 200? X plus Y, right? X represents the number of scientific calculators. Y represents the number of graphing calculators. And at least, like if I say I'm going to give you at least $5, I'm going to give you 5 or more, right? So if they say you've got to make a total of at least 200, okay, greater than or equal to 200, okay? Okay, those are our constraints. Then we need the equation. It says if each scientific, the function equation, if each scientific calculator sold results in a $2 loss, but each graphing calculator produces a $5 profit, how many of each type should be made? Okay, so the profit, and you can write it, I don't care, I use P for profit, but you could use F of XY also. You're going to lose on the scientific -2 times the number of calculators, but you're going to make $5 on the graphing ones. Okay, so there's your function. You see where that comes from? Why is it -2? Because you're going to lose. Okay, now we're just going to do a little sketch of the graph over here, but not on graph paper. Okay, just in general. Okay, so X. If I did just this much, if I said X equals 100, what kind of a line is that? Vertical line at X equals 100. So vertical line at X equals 100. Okay, so this is my X equals 100. And then if I did just this part, if I did X equals 200, that's another vertical line at X equals 200. Okay, but now I have to go X is greater than or equal to 200, or greater than or equal to 100, and less than or equal to 200. So the shading is in between. Okay, so, and I'm going to shade it with this, so we've got this much shaded. Okay, everybody with me so far? Okay, and now we're going to do this part. Read it from the Y. Y is greater than or equal to 80. So Y equals 80. Horizontal line at Y equals 80. Greater than would be up above. Okay, Y is less than or equal to 170. Okay, so say this is where Y equals 170. So the Y is greater than or equal to 80 and less than or equal to 170. Okay, so in between, right? So do you see the overlap so far looks like a box? Okay. Okay, now we have to graph this, solve for y. So we'd have y is greater than or equal to, subtract x plus 200, right? You agree with that? If we subtract x on both sides. So it's going to go through at 200 and slope of -1. Okay? Okay, so I know it's coming, okay, and I need to look at it. So now we go to the calculator. Okay. Everybody grab your calculator. Okay, and for the first one, we cannot do the vertical lines, but we can do an x equals. Okay, so let's do on the vertical or the horizontal lines first. Let's do 80, y equals 80, and y equals 170. Okay, and for the window, okay, I want to show part of this, so I'm going to go -50. I don't need all that. Let's go negative. Let's go -10. We may have to adjust that. For the x max, how far over did our vertical line go? 200. So let's go maybe 300, and I might need to change it. And I don't really need the tick marks. So to turn off the tick marks, put 0 in for the x scale. Okay. For the y min, I still want to see the axis. So I'm going to go -10. For my y max, I know this one graph, it's going to cross at 200. Let's go maybe 300 on there too. And scale 0. And we can change the window if we need to. Okay, so let's just graph that much. Okay. Now let's graph this, and let's do it as it's an equal sign. So let's graph in y sub 3. So let's graph -x plus 200. Okay. So far I have in y sub 1, I just am graphing 80. That's that horizontal line. In y sub 2, I'm graphing 170. That's the other horizontal line. In y sub 3, I'm graphing -x plus 200. Okay, and let's graph that. Okay. Okay, now I need to figure out where are my vertical lines. Okay, the only way I can do that on the calculator, I can't graph them, but I can see where they're at. So right above the trace key, do second function calculate value. And what's our first vertical line? 100. Okay. So vertical line. So it is a vertical line. Looks like it's going to go like this. Okay. Yes. Hang on. Hang on. So if you do second function calculate value, it's giving you that point on that vertical line. That's where that ordered pair is. Okay. And if you look down below, it's at 180. Okay. And that's where our ordered pair is on our graph. Okay. Let's do the other one. Do second function calculate value at x equals 200 and 280. So that's showing you this one. Okay. So here's our final. This part right here. Okay. That is our overlap part right there. Okay. Notice it does not include this little corner right here. So we have to go through and find, let me mark it differently. We have to find this ordered pair, this one, this one, this one, and this one. That is our feasible region. That's our dark region. Okay, so what ordered pair is this one right here? Okay. What's the x value? This is x value is 100, and which line is it on? It's on the x's is 80, but what line? It's the red line, isn't it? Okay, so do second function, calculate value at x equals 80. Okay, that is not the one we want. The calculator is going to cycle up and down through all, like if you had 5 equations, it's going to cycle through all of them. Okay, so that's not the one I want. Use the arrow key. Okay, is that on the right line? Yes, so that ordered pair is 80, 120. Okay, now what is this ordered pair? That one you can figure. The x is 100, the y is 170. What is this ordered pair? That one you can figure. X is 200, y is 170. This one, x is 200, y is 80. And now we need to figure this one. What do we know about that one? Y is 80. So take that inequality, take that and let 80 equal. Right? Subtract 200. Negative 120 equals a negative x, so x equals 120. So for that one, the x is 120 and the y is 80. Okay? Okay, are we good there? Okay, so now we know all the ordered pairs. Now we have to go back and sub into this function. So let's start with the 80, 120. Okay? Now, we're going to do this on the calculator this time. We're going to make this easier. Okay, on your calculator, go back to the home screen. Do second function quit. Take negative 2, and then in parentheses put 80, plus 5, and then in parentheses put 120. Okay. Wait, did I write that right? No, I didn't. No, I didn't. Yeah. No, it's the other way around, right? 80 is the... Sorry. Gosh, darn it. So this is 120, 80. Sorry. So turn these around. Okay, so now on your calculator, we need to put that back in. So it'd be negative 2 times 120. Close the parentheses, plus 5 times 80. You can put that in parentheses too if you want to. I get 160. Okay. Okay. Now go to the next ordered pair. Did I mess that up all the way around? Was this ordered pair right? 80, 120? Well, I could have kept that then. Okay. Okay, now on your calculator, just go in, do second function, entry, right above the enter key. This might be the first time we've done this. Do second function entry. So it should retype that. Now we're just going to go back in and change that to right above the enter key. You need to hit the delete and make that negative 2 times 80 plus 5 times 120. And I got 440. 440. You agree with that? Okay, and then 100, 170. So let's try. The X is 100 and the Y is 170. So right above the enter key, do second function entry. We need to type over the 80, make that a 100. You're going to have to do second function insert. Right above the delete key, do second function insert, and insert a 0. Plus 5 times 170, change that 120 to 170, and I got 650. Okay, keep going around. I need 200, 170. Gosh dang it. Okay, 200, 170 should be 450. The 280 should be 0. Okay, and I think we've gone away. Okay, so the max, if they ask back here, how many should you make to produce a max? Your max profit is 650 at 100 scientific, 170 graphing. Okay, so 650, 100, okay. Okay,